Welcome to Mechanical Engineering Learning Channel. In today's video, we will discuss the project of calculating mechanical work quantities and how to extract them using Excel. Stay tuned. In this project, we will calculate the following quantities: pipe lengths, number of fire cabinets, collector pipes, fire department connection points, traceable butterfly valves, as well as all other components in the project. This is the Excel file, which contains the names of all components in the project. We will review the drawings, calculate the quantities, and then enter them into this list. We will calculate the number of fire cabinets using the Select Similar feature. Based on this feature, there are 45 fire cabinets. Now, I will search in the list and add the number. After that, I will search for the fire department connection points in the project, which are used to connect pipes to the firefighting system, ensuring that water or firefighting materials reach the fire locations. After identifying the points, I will add the number to the quantity list. The number of fire department connection points is 19 points. It is important to verify the number multiple times and pay attention while extracting quantities using multiple methods to ensure accuracy. If you have any project, I can assist in extracting quantities within a certain budget. Feel free to contact me. Now, we will move on to calculating the quantities of pipes used in the project. There are multiple types that can be used in fire protection systems, such as black steel pipes or galvanized pipes. The choice of type depends on the hazard level of the location. If the location is highly hazardous, galvanized pipes should be used. If the location is standard, steel pipes can be used. In our project, the pipes used are black steel pipes. These pipes vary in sizes, starting from ½ inch and then following sizes such as 1, 2, 3, 4, 5 inches. It is essential to know the appropriate pipe size that will be used to feed the entire system to ensure there is no deficiency and to guarantee its efficient operation. This is the feature used in the project to calculate the total amount of pipes used. After selecting the pipes, you can click on this feature to get the total number of pipes used in the project. If you want to access this feature, please type LSP in the comments. Explanation about LSP. LSP stands for Lisp Script, which is a feature or tool used in engineering design software like AutoCAD. This feature allows you to execute custom commands or specific actions quickly, such as calculating quantities or summing measurements automatically. After completing the quantity calculations, we proceed to price these quantities and send them to the company or project owner. If the pricing is accepted, we will then proceed with implementing the project on site. These works include fire protection systems, sanitary systems, ventilation, cooling, heating, and all mechanical-related works in the project. Through mechanical engineering, we ensure the safety and efficiency of the systems in operation, meeting the required standards for the project completely, including material selection, engineering design, and the execution of various systems on site. I will now leave you with the video. Enjoy watching. Before leaving you with the video, I would like to explain a little about mechanical engineering and its importance in this project. Mechanical engineering is one of the fundamental and essential branches of engineering, concerned with the design, analysis, manufacturing, and operation of machines and systems. It is a key element in many industries, including energy, automotive, manufacturing, and thermal systems. In this project, mechanical engineering plays a critical role in designing mechanical systems, such as fire protection systems. Through material selection, such as pipes, fittings, and control valves, we can ensure the safety and efficiency of the system's operation at the highest possible level. Accurate calculations and choosing the right tools and equipment are some of the most important aspects of mechanical engineering that contribute to the success of the project and meet safety standards. Therefore, understanding mechanical engineering and the ability to apply its principles in practical projects is crucial for achieving the project's objectives. In the next video, we will extract quantities for a sanitary project. But before we dive into that, let's take a moment to understand the importance of fire systems and sanitary systems in engineering projects. Fire systems are one of the most important engineering systems in any construction project or facility, as they aim to protect lives and property from the danger of fire. Fire systems include many components, such as sprinkler systems, carbon dioxide fire suppression systems, and fire alarm systems. A key factor in designing fire systems is the selection of appropriate pipes and equipment, as the pipes must be able to withstand high temperatures and pressures. In this context, pipes and connectors are chosen based on the size of the area and the flammable materials within it. One of the critical aspects in designing fire systems is ensuring complete coverage of all spaces and areas in the building to ensure that water or gas reaches all potential fire-prone areas. The systems must also be subject to regular maintenance and checks to ensure their functionality at all times. Sanitary systems. As for sanitary systems, these are the systems that manage the transportation of contaminated water and waste away from buildings or facilities to treatment plants or appropriate disposal areas. Sanitary systems include sewer pipes, lift stations, and water treatment systems. Designing sanitary systems requires great precision, as pipe sizes are determined based on the population of the area or the size of the facility. Additionally, elevations and slopes must be considered to ensure that water flows smoothly and naturally. The system's components also include treatment plants, which play a key role in purifying water before it is released back into the environment, as well as safe disposal systems for treated water. Sanitary systems must also be maintained regularly, as blocked pipes or issues with stations can lead to environmental contamination and health problems. Integration of fire and sanitary systems. It is essential to coordinate between these systems in the project, as care must be taken to avoid conflicts between pipes used in both systems. Moreover, the selection of materials and the engineering design in these systems should consider space efficiency and operational efficiency under all conditions. One of the most important elements of fire systems is the sprinkler system, which is one of the most widely used and effective systems for fire protection. This system relies on sprinklers that are installed in specific locations within a building or facility to combat fires quickly and effectively. Types of sprinklers. Mechanical sprinklers. These types of sprinklers operate using a mechanical head that breaks when the temperature reaches a certain point, allowing water to flow and extinguish the fire. They are mainly used in areas that require protection from high fires. Thermal sprinklers. These sprinklers contain a heat-sensitive head, and when the temperature reaches a certain level, a thermal link breaks, allowing water to flow. They are used in areas where a fire is not expected constantly, but the system must be ready to respond when it occurs. Vertical or horizontal sprinklers. The type used is determined based on the room or space. Horizontal sprinklers are commonly used in corridors or large rooms, while vertical sprinklers are used in areas with low ceilings or limited spaces. Specialized sprinklers for hazardous materials. These types of sprinklers are designed for areas that contain flammable or hazardous materials. They are specifically designed to be more effective at extinguishing fires in high-risk environments. How sprinklers are used. Sprinklers are strategically distributed on surfaces or walls within each room or space, ensuring even coverage across the area. Engineering calculations are essential to determine the optimal number and distribution of sprinklers based on the room size and type of activity, office, commercial, industrial, etc. Temperature control is key to the operation of the system, with sprinklers activating when the temperature rises above a set threshold. When to use sprinklers. In public places and buildings that contain flammable or hazardous materials. In tunnels and enclosed parking lots, where access to a fire is difficult. In industrial facilities, where there is a high risk of fire due to equipment or flammable materials. In hotels, hospitals, and large residential buildings where fire sprinkler systems are required by law for comprehensive protection. Advantages of the system. Rapid response. the sprinkler extinguishes the fire quickly before it can spread and cause severe damage. Heat control, the system helps to reduce the temperature in the fire area. Self-protection, the system operates automatically without the need for human intervention. Maintenance and testing, sprinkler systems must undergo regular maintenance and inspection to ensure they function properly. This includes testing sprinklers to verify that thermal links are intact and that pipes are not blocked. Fire tanks are water storage systems used in firefighting, and they are one of the essential components in fire protection systems. Their main function is to provide a stable and continuous water supply for use in case of a fire. These tanks are used in mechanical systems, especially in sprinkler systems and other firefighting systems like hoses and connected pipes. Types of fire tanks, overhead tanks. These types of tanks are common in many buildings. They are installed on rooftops or high parts of buildings and are filled with water to provide continuous water pressure in case of a fire. Special pumps are used to pump water from the tank to the pipes leading to the sprinklers or hoses. Ground tanks. These tanks are installed in the ground or in the lower floors of buildings. They are often used in large areas or industrial buildings. These tanks generally have larger storage capacities and require powerful pumps to deliver large volumes of water quickly. Closed water tanks. These tanks are used in areas with limited ventilation, such as warehouses or industrial areas. They are covered to prevent contamination from dirt or environmental factors. Pressurized water tanks. These tanks use pressure technology to maintain constant water pressure, ensuring that water flows faster and evenly when the system is activated during emergencies. Standards and laws for using fire tanks. The regulations for fire tanks differ from country to country, but there are global standards and principles adopted in many countries to ensure the effectiveness of the tanks. Some of the most important regulations include, tanks in public areas. All large buildings or public facilities, such as hotels, hospitals, schools, commercial buildings, must have fire tanks that match the size of the building and its usage density. Quantity rate. According to some historical laws, a fire tank is required for every 30 square meters in buildings. This means that if the total area of the building is 600 square meters, at least 20 tanks must be provided. Required precautions. Many countries require that the tank holds an adequate amount of water that equals the amount needed to run the system effectively throughout the duration of the fire. Backup tanks. An important requirement is that backup tanks should be provided to ensure the continuous water supply in case of a fire. These tanks should be protected from any contamination that could affect the water quality. How to calculate the required tank size. Calculating the size of the fire tank depends on several factors, including the number of sprinklers and outlets to be used, the required water pressure for effective system operation, the size of the area or building and the type of activity, e.g. industrial or residential. Based on accurate engineering calculations, the required tank size can be determined. The tank must be capable of providing sufficient water for the system to operate efficiently. Technical specifications for fire tanks. Sturdy structure. Tanks should be made from corrosion-resistant materials, such as stainless steel or galvanized steel, to ensure durability in a long service life. Proper connections. The tank should be properly connected to the pipe system and hoses leading to the sprinklers or water pumps. Regular inspection. Tanks should undergo regular checks to ensure there are no leaks or blockages that could impact the tank's ability to store or deliver water effectively. Advantages of fire tanks. Ensures continuous water supply. A fire tank ensures that water is available during emergencies for the system to operate. Quick response to fire. Providing enough water in emergency situations reduces response time and increases success rates in extinguishing the fire early. Compliance with regulations. Installing fire tanks ensures compliance with legal requirements in many countries and regions to guarantee safety in the building. Fire tank maintenance. To ensure the effectiveness of a fire tank, regular maintenance should be performed. This includes checking the water levels and ensuring there is no contamination. Testing the pumps to ensure the tank operates well under the required pressure. Inspecting pipes and connections to ensure no leaks are present. The collector is a device or unit in engineering systems used to distribute liquids or gases evenly or collect them from multiple sources into one source. This type of device is used in various mechanical systems such as fire protection systems, heating systems, ventilation systems, as well as in pipes that transport liquids across buildings and industrial facilities. Types of collectors and their uses. Collector in fire protection systems. In fire protection systems, the collector is used to gather firefighting water from multiple lines and distribute it evenly to different points such as sprinklers or fire hoses. The collector ensures effective water distribution throughout the system, guaranteeing that water reaches areas in need during emergencies. Collector in heating and ventilation systems. Collectors are also used in heating and ventilation systems to gather and distribute hot or cold air evenly throughout the building. The collector is connected to air ducts that carry air to rooms or areas requiring heating or cooling. Collector in piping systems. In some systems that rely on pipes to transport fluids, such as sewage systems or irrigation, the collector is used to gather fluids from multiple sources and direct them to a single line or central system. Function of the collector in engineering systems. Even distribution. One of the main functions of the collector is to distribute liquids or gases evenly across multiple points or a single system. In fire protection systems, for instance, it ensures that water reaches all sprinklers with equal quantity and pressure for effective firefighting. Flow control. The collector also helps in controlling the flow of fluids by regulating pressure and the amount distributed through the different pipes. This helps prevent overpressure or leaks that could arise due to imbalance in flow. Space and efficiency. Collectors can reduce the need for multiple connecting pipes, as they allow several lines to be connected at a single point, thus saving space and reducing complexity in systems. Materials. Collectors are made from corrosion-resistant materials such as stainless steel or galvanized steel to ensure durability and long-term performance under harsh conditions. In fire protection systems, bronze or steel collectors are commonly used due to their resistance to corrosion caused by water. Design. The collector should be designed in a suitable manner to ensure fluid flow is efficient with minimal resistance. The design depends on the type of fluid or gas being transported and the pipe size. Dimensions. The size of the collector depends on the system size and the flow of fluids or gases. Smaller collectors are used in smaller systems such as residential buildings, while larger collectors are used in industrial systems or large projects, such as fire protection collectors in large buildings or industrial facilities. And now, we've reached the end of the video. We hope you enjoyed it and found it beneficial. Don't forget to subscribe to the channel to stay updated with all our new content, and activate the notification bell so you'll be notified whenever a new video is uploaded. If you liked the video, please show your support by giving us a thumbs up, as it motivates us to create more valuable content for you. If you have any questions or comments, feel free to leave a comment below the video, and I will be happy to answer them. Thank you for watching, and see you in the next video with fresh and useful content.